No, you will answer. Okay. Tell me the others except him. What made you to sit here? Simply for killing the time or for chatting purpose? No, all are busy in chatting. Am I right? Right. May I know what we discussed in the previous class? One answer. Only one answer. That too by standing. You have to speak, please. Yes, boys. You. I know you can answer. Other than you. Yes. Over. Arrangements over. Chappi. So what we discussed in the previous class? Boys, backside boys. Can anyone share? What happened, boys? Tell me what we discussed. We discussed about crystallography. Am I right? So, what are the titles that come across in that unit? One answer, please. Amma, please stand. Remaining, please. Enough. Yes. Please. Unit cell. Unit cell. Next. Lattice point. Lattice parameters. Interfacial angles. Yes, please continue. Who is that? The taller in the class, huh? From back. The taller. You only. Stand. You are the tallest boy according to me. Please stand. Yes, tell me. Good. Basis. Stand and say. Vishnu. Basis. Good. Inka? Your friends said one answer. You also say. I'm asking questions. I'm not asking answers. అసలు నీకు క్రిస్టలోగ్రఫీలు ఏం తెలుసు చెప్పు విన్నావా అసలు క్లాసే వినలే గ్రేట్ రెగ్యులర్ క్లాస్లో ఏమి విన్నా చెప్పు ఫిజిక్స్లో రెగ్యులర్ క్లాస్లో ఫిజిక్స్ సబ్జెక్ట్ ఏం విన్నావు ప్లీజ్ వాట్ హ్యాపెన్ వాట్ మేక్ యూ టు షౌట్ లైక్ దిస్ Anybody from this side? Say something. Yes? Crystal structures. Good. Solid. Good. Cubic structure. Good. ఇంకా ఆలోచించు అట్లే crystal structures. This side. Can you give an example? What are the different crystal structures that were being discussed? Think and say. Yes? Stand and answer, please. Primitive cell. Primitive cell. Okay. Tell me what is primitive cell? This side. Your friend is asking question, primitive cell. Can anyone answer? What is the difference between unit cell and primitive, simple cell and primitive cell? Stand. Unit cell contains lattice points. Primitive cell? Gatiga. Okay, primitive cell contains lattice points. What about okay, non-primitive cell? Non-primitive cell, primitive cell difference enti? Or simple cubic cell, primitive cell difference? Primitive cell lo one lattice point. Okay. Non-primitive cell? More than one lattice point. Okay. Simple cube? 6? 6 lattice points, huh? 6 is an answer. What is the question for that? Okay. 6 he said. 6 word is there in this unit. I think number is, we are using this 6 number anywhere else. ఈ యూనిట్లో ఎక్కడ యూజ్ చేస్తున్నామా 6 అనేది? ఎక్కడ ఉంది? దట్ నెంబర్ we are using in this unit. ఎక్కడ? ఓకే, ఫేస్ సెంటర్డ్ క్యూబిక్ క్రిస్టల్ కంటైన్స్ 6 ఫేసెస్. కరెక్టా? అంతేనా? గుడ్. ఫేస్ సెంటర్డ్ క్యూబిక్ క్రిస్టల్ కంటైన్స్ 6 ఫేసెస్. ఇంకా ఎనీ అదర్ ప్లేస్? క్యూబ్ ఆల్సో 6 ఫేసెస్. ఓకే, గుడ్. ఇంకా? ఓకే, లెట్ us keep that faces aside. Any other? No, other than face. As per syllabus, how many crystal systems are there? Okay. Crystal structures. Simple cube, BCC, FCC. Yes or no? Simple cube, BCC, FCC. Now tell me 6 number with respect to this 3. అర్థమైందా క్వశ్చన్? సింపుల్ క్యూబ్లో యూజ్ చేస్తామా, బీసీసీలోనా, ఎఫ్సీసీలోనా 6 అనేది? ఎందుకు? వై? నాకు క్వశ్చన్ ఈస్ క్లియర్? సింపుల్ క్యూబా, బీసీసీయా, ఎఫ్సీసీయా? సిక్స్ ఫేసెస్ అన్నారు, ఐ విల్ యాక్సెప్ట్ ఇట్. ఇంకా నేను మీకు హింట్ ఇచ్చాను. సింపుల్ క్యూబ్, బీసీసీ ప్లస్ స్టాండ్. సింపుల్ క్యూబ్ కోఆర్డినేషన్ నంబర్ 6. గుడ్. వేర్ వి యూస్ కోఆర్డినేషన్ number purpose in simple cube. What is the meaning of coordination number? She said that in simple cube, coordination number of simple cube is 6. What is coordination number? What is coordination number? What is coordination number? Girls, only one girl is standing and responding, remaining. Coordination number ante enti? Stand amma. Stand, no problem. Coordination number ante? Amma? Yes. Nearest neighboring atoms. Equidistance, unequal distance? Equal distance atoms. How 6? Can anyone explain? 6 ఎట్లా అవుతాయి సింపుల్ క్యూబ్లో? Nearest equidistant atoms 6 in the simple cube. How? థింక్ చేయండి. వేర్ వి ఫైండ్ ఆటమ్ ఇన్ క్రిస్టల్? ఎక్కడ క్రిస్టల్ ఎక్కడ ఉంటుంది ఆటమ్? దాన్ని ఏమనాలి? ఆల్రెడీ ఐ గాట్ దిస్ ఆన్సర్ ఫ్రమ్ యూ. ఆ పాయింట్ ఏమంటాం? lattice point. So in simple cube, 3-dimensional picture, one lattice point, and check. Kuchama, good. Classroom, can we take an example for simple cube? How many lattice points are there in this classroom? What is shape of this classroom? What? Cuboid. Okay, how many lattice points are there for this cuboid? 8. Can you show that corner? Right. Now with respect to that corner, count the number of neighboring atoms of equal distance. కార్నర్ ఆటం తీసుకొని కౌంట్ చేయండి. ఎన్ని పాసిబిలిటీస్ ఉన్నాయి? ఎట్లా 8? మీరే ఇమాజిన్ చేసుకొని చెప్పండి. వాట్ ఎవర్ ద నెంబర్ యూ ఆర్ సేయింగ్, యూ హ్యావ్ టు సపోర్ట్ ఇట్. స్టాండ్ 6. ఎట్లా చదే ఎటు 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 చెప్పు. అక్కడ అదే అనుకో, ఆ పాయింట్. ఇప్పుడు చెప్పు, ఆ పాయింట్ చెప్పు. ఎక్కడ? ఈ కార్నర్ నుంచి ఆ కార్నరా? ఒకటి. ఇంకా ఆ కార్నరా? 2. ఇటువా? 3. 1 2 3 కదా. క్యూబ్, ఇదే క్యూబ్, ఇదే క్లాస్ రూమ్. ఇప్పుడు చూపించు. ఓకే, హీ ఈస్ ట్రయింగ్. రిమైనింగ్, take that corner. It is not a cuboid, but it is cube, you think. That atom, how much distance? That atom, how much distance? That corner atom, how much distance? How many completed? 3. We can assume that side also same 3 or not? 4 in one plane, 1 below, 1 above. Total how many? 1 2 3 4 5 6. Draw. Show. 6. Show to me. Draw. 1 2 3 4. అది డయాగనల్ డిస్టెన్స్ ఈక్వల్ ఎట్లయితే? డయాగనల్ డిస్టెన్స్ కదా. I'll draw on the board. One unit cell of a 3-dimensional cube. 1 2 3 4 5 6. If it is difficult, that corner you take, or I have to extend this in 3D. This atom 1 2 3 4 5 6. Remaining will be not equal to A. It will be other than A. So how much it is? 6. Okay, right. Okay. How many atoms are there in the unit cell? How many atoms are there in the unit cell of simple cube BCC FCC? Number of atoms in the unit cell of simple cube BCC FCC. How many? Number of atoms present in the simple cube BCC FCC. How many atoms? Number of atoms in simple cube 1. BCC 2. FCC 4. How 1? How 2? How 4? How 1? How 2? How 4? ఎట్లా 1? ఆ రోజు డిస్టర్బ్ అయిన క్లాస్ ఇదే కదా లాస్ట్ సాటర్డే. ఓకే, కొద్దిగా ప్రీవియస్కి వెళ్ళి తెలుసు వీళ్ళకి ఫస్ట్ టైం అనుకుంటా. లాస్ట్ ఆల్రెడీ డిక్లరేషన్ రోజు పోయారు కదా. దట్ కింద. ఓకే, హౌ మెనీ ఆటమ్స్ ఆర్ దేర్ ఇన్ ద సింపుల్ క్యూబ్? BCC, FCC 1, 2, 4. హౌ అమ్మా? How many atoms of simple cube? 1. BCC 2. FCC 4. How? ఎట్లా? Tell me, one of you. Every corner atom has 1/8 part of atom. Why 1/8? The same thing you speak in English. The contribution of each atom for unit cell is 1/8. Okay, why 8? 1/8. నువ్వు చెప్పింది ఇంగ్లీష్లో రిపీట్ చేయి. ట్రై చేయమ్మా. అంత విఐపీస్. నాకు కూడా ఇంగ్లీష్ అక్క రాదు, పర్లేదు మార్చాయి. చెప్పమ్మా, చెప్పు. ఎవ్రీ భయం పోతేనే సబ్జెక్ట్ వస్తుంది, మాట్లాడడం వస్తుంది. చెప్పి ఎవ్రీ సైడ్ హ్యాస్ అనదర్ క్యూబ్. ఓకే, atom shares with how many? It is sharing with 8 other unit cells. Good. Every atom is a part of 8 unit cells. So contribution will be 1/8. Etla 1/8? How 8? Can anyone imagine the picture? Each corner atom sharing with 8 other unit cells. Statement okay na? ఒక ఆటం ఎన్ని ఆటమ్స్ షేర్ అయి ఉంటాయి? ఎన్ని యూనిట్ సెల్స్ షేర్ అయి ఉంటాయి? సో ఇమాజిన్ ద పిక్చర్. ఇమాజిన్ చేయొచ్చా? ఇమాజినేషన్ అయిపోయిందా? దట్ ఇమాజినేషన్ కీప్ ఇన్ వర్డ్స్. చెప్పండి, ఇక మన ఎగ్జాంపుల్ తీసుకొని చెప్పండి. యూ నాడెడ్. గుడ్. ఎస్, ఎస్, దట్ పాయింట్, కెమెరా పాయింట్. ఈ రూము, పక్క రూము, దాని అటు రూము, దానికి అటు రూమ్. ఎన్ని మొత్తం? 4. దీనిపైన 4. ఇప్పుడు ఇంగ్లీష్ చెప్పి, తెలుగులో అందరూ చెప్తారు. దిస్ రూమ్, బిసైడ్ రూమ్, బ్యాక్ రూమ్, బిసైడ్ రూమ్, బ్యాక్ రూమ్, బిసైడ్ రూమ్. వేర్ ఫోర్? ఇన్ దిస్ ప్లేన్. సేమ్ ఫోర్ అబోవ్ ప్లేన్. ఓకేనా? ఏమ్మా పడుకునేందుగా? గుడ్ ఆన్సర్. ఇఫ్ యూ టేక్ దట్ పర్టికులర్ పాయింట్, దిస్ వన్ రూమ్, beside one room, back side one room, back side one room. 4 rooms in this plane, 4 above. Each room is 1 unit cell. Total how many? 8 rooms, 8 unit cells. So that 8, that corner is common to how many? So what is the contribution for each room? What is the contribution for each room, Mr. Hero? What is the contribution? పోయింది కానీ. Stand. Okay, no. అన్నీ మాయమవుతాయి కానీ. Stand. What is the contribution? 8. How much? 8 rooms, 8 contributions. వింటుండా? 8 rooms, 8 contribution. Total 8 into 8, 64. You are saying 8 1 by 8, which is the correct answer. Right. So, like that, how many corners are there? 8. 8 into 1 by 8 is 1. In the case of simple cell. Coming to BCC. What is the full form of BCC? Body centered cubic crystal. How many atoms are there in BCC? లేపండి సార్ అవన్నీ ఎక్కువైపోయిందా అసలే లేదా నిద్ర వస్తుందా హౌ మెనీ ఆటమ్ వాట్ ఇస్ ద ఫుల్ ఫామ్ ఆఫ్ బీసీసీ మిస్టర్ బీసీసీ ఫుల్ ఫామ్ వినలే సింపుల్ క్యూబ్ అంటే ఎస్సీ అంటే BCC full form body centered cubic crystal. How many atoms are there? What is the, how to represent BCC? Okay, so what I do? Wait. Amen. It is a three-dimensional picture. Can you imagine? Or if I draw like this, it will be like this. (3D). The same thing I can show like this. Imagine, can you imagine this? Here also 8 atoms will be there. Unit cell of a BCC. Now the center cell near to how many? 1, 2, 3, 4 in this plane, 4 below. Total 4 plus 4, 8. Total number of atoms? 8 into how many corner atoms? Their contribution plus center of the cell how many? So total how many? 1 plus 1 is how much? 2. This is one lattice point. This is also one lattice point. The distance between two lattice points is A. This distance is also A. What about this distance? Apply the Pythagoras theorem. If I say this is A, this is B, this is C, what is AC? Under root of AB square plus BC square, which is equal to under root of A square plus A square is equal to how much? Root 2A square, which is equal to root 2. So this is how much? Root 2A. This is what? Root 2A. How much? From here to? Now, A, B, C, D. What about this distance? A. What about this distance? What is DC? DC. Use triangle DADC from triangle ADC. What is DC? DC is equal to what I can write now? Under root of dA square plus AC square. So what is DC? What is dA? A square. And what is AC? AC. Root 2A whole square. This will be how much? A square plus 2A square, which is equal to root 3A square, which is equal to root 3A. What is root 3A? D to C. So what is this? That is how much? Root 3A. Now if this circle center, right, this is one circle radius R, this radius is R, this radius is R, this radius is R. If I draw like this, it will come. This is D and this is C. So this length, how much you got? Root 3A. Now what is this? R, 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 R. How many? Is equal to how much? 4R. So what I can write now? 4R is equal to root 3A. Therefore R is equal to root 3 by 4A and A is equal to 4 by root 3R. Kani, I will wait. Urgent, emergency, essential. Kani, come out. Please. Randy sir. Find it for basis. ట్రై చేయి. ఎందుకున్నా ఇక్కడ దాని పర్పసా దేని పర్పసా? మరి అదేం చేస్తుంది ఇక్కడ? సింపుల్గా తెలియదు అంటున్నావు. ఫ్రీగా చదువుతున్నావా పేమెంటా? ఫ్రీ ఎడ్యుకేషన్, పెయిడ్ ఎడ్యుకేషన్. ఫర్ వాట్ పర్పస్? మొబైల్ కోసమా? ఇప్పుడు తర్వాత అర్థమవుతుంది. సరే, చూడు, చెక్. డన్. చూసుకో చూసుకో. చూసావు కదా? షో. One request from my side. Black, come here. Same question. Can you prove relation between R and A? Simple cube. Okay, right. For simple cube. Right. It is what? What you said? Simple cube you said. It is simple cube, huh? It is simple cube. Bye. Use this surface.
Vehicle train in
7 అనుకుంటా. 5 వరకు వచ్చామని.
ఇంటికి రమ్మంటారు.
5 వరకు రమ్మన్నాడు, ఎందుకంటే పోయి మేము బ్రేక్ఫాస్ట్ చేస్తాం కదా బయట. 5 వరకు రమ్మని చెప్పండి.
5 కరెక్ట్ అంటే 4:45 చెప్తే 5కి వస్తారు. మీకు 4:20 4:15 వరకు మీకు సెక్షన్. దాని తర్వాత మీరు వెళ్ళి లగేజ్ సరే పర్వాలేదు.
Who want? ఓకే, చేస్తా. వీళ్ళకి ఈ యూనిట్ అక్కడ గుర్తుంది నాకు. ఓకే రైట్. ఇదే వినక అంతే. It is what? Simple cube you made complicated. Simple cube you are making complicated. Why you are getting this problem? Because you are not observing when the lecture is. మరి చెయ్యి కిందికి, తల కిందికి ఉంది. ఓకే రైట్. Right. So already for BCC I shown you how to find the relation between lattice constant and radius. For simple cube the relation between them is A is equal to 2r. For BCC A is equal to 4 by root 3r. For FCC A is equal to 2 root 2r. I think A is equal to 2 root 2r. Why we use these equations? Because we have to find packing fraction. Exam point of view, simple cube, BCC, FCC, important. For that purpose I am saying packing fraction is nothing but what? It is a ratio between volume of atoms present in the unit cell divided by volume of the unit cell. So in simple cube only one atom is there, so 1 into V by capital V. For BCC 2 atoms are there, 2 into small v by capital V. In FCC 4 atoms are there, 4 into small v by capital V. So same result will come, different result will come. Okay, so for that purpose if you want to find V, capital V, volume of the atom, where A cube in terms of radius, it is same. A is equal to 2r, A is equal to 4 by root 3r, A is equal to I think 2 root 2r. So as the A value is changing, V is equal to A cube. So volume will be equal to A cube. Same volume will come. Volume of this will be same. This will be used for finding packing fraction, which is equal to n into small v by capital V formula. In simple cube this value is 1. 2 in the case of BCC, 4 in the case of FCC. What is small v? Volume of the atoms present in the unit cell. What is the formula for finding volume of the atoms? 4 by 3 pi r cube. And what is v? Volume of the unit cell. Formula is a cube. Okay, right. Now in this class, we are going to discuss about dielectrics. What are dielectrics? Dielectrics. Where these dielectrics are used? Have you heard about this word or for the first time you are listening? Dielectrics. విన్నారా ఎప్పుడన్నా? వినలే? Dielectrics. విన్నారా లేదా? No. Have you heard about capacitors? Capacitors విన్నారా? Capacitor అనే వర్డ్ విన్నారా లేదా? Okay, done. Where these capacitors are used in our daily life? ఎక్కడ యూజ్ చేస్తాం? In computers. Good. ఇంకా? In electronics. Simple answer. Good. ఇంకా? In computers, in electronics. Application of electronics, computer. Good. ఇంకా? Have you seen? Is it visible? Now, as per my knowledge, there one laptop is there. Here one sensor board is there. These are also computers, I can say. Can you see in a capacitor? You know that they are used. You know that they are used in the manufacturing of a laptop, sensor boards, etc. But are they visible? కనిపిస్తున్నాయా? My language is okay or shall I go slowly? Right. Any capacitor is visible? కనిపిస్తున్నాయా? No. Give an example where you can see. Huh? Motherboard is visible? It is available in the market everywhere? Huh? Yes, speak. Stand. Good. We can see capacitor in fan. Fan is there in every home. Yes or no? Sir, even mobile is also there. Okay. But if you want to see the components, we have to open it and we have to see. We have to open it and we have to see. But without opening, we can see the capacitor. Okay. Morning, Rasmit. So, one example is fan. So, in fan, capacitor is there. How it looks? Cylindrical in shape. Chusarama? Girls? Okay, right. What is the color? General color? White or grey, light grey. Okay, right. Clarity is there. Just if you remove the top cap, which is there just above the rotating disc, that cylinder you can see it. Kept horizontally. Yes or no? Right. My question is why it is called capacitor? Why that capacitor is used? ఎందుకు కెపాసిటర్ ఫ్యాన్లో యూజ్ చేస్తారు తెలుసా? Capacitor, remove the capacitor and switch on the fan. What you are going to see? Yes? Speak louder. Good. It won't work, huh? Huh? Yes. It goes slowly. What goes slowly? Rotation of the fan will be, means let us use the word RPM, rotation per minute will be less. Yes or no? So what you have to do to increase the RPM? What the electrician will do? Or known people what they do? They replace the old capacitor with a new capacitor. So that RPM is going to increase. Antena? Right. So you know where capacitors are used. Any other example other than fan? Yes, motor. Motors, you know, where motors, which motors? Water motor. Water motor, you know, there also capacitors are used. In where they are fixed in water motor, along with motor, where they are fixed in water motor. ఇంట్లో అందరికి బోర్వెల్ ఉందా లేకుంటే వెల్ ఉందా? బోర్ ఆర్ నార్మల్ వెల్? బోర్. టు లిఫ్ట్ వాటర్, submersible pump you are using, or motor which is fixed along with that pipe is used? Submersible అంటే తెలుసా? Which is dipped in water, submersible. ఇంకొకటి ఏంటి? It is there, we can see, which is erected vertically పైన పెట్టుంటే ఒక స్టాండ్ మీద. చూసారు ఇట్లాంటి మోటార్స్? ఓకే, మోటార్ ఈస్ దేర్. ఇఫ్ యూ వాంట్ టు రన్ ద మోటార్, వాట్ యూ విల్ డూ? ఏం చేస్తారు? వాటర్ రావాలంటే ఏం చేస్తారు? స్విచ్ ఆన్ చేస్తారు. ఎక్కడ? ఎస్, ఓ బోర్డు ఉంటుందా? ఆ బోర్డ్ ఈస్ కాల్డ్ ఎస్ స్టార్టర్. ఎనీ టైమ్ హ్యావ్ యూ ఓపెన్ ద బోర్డ్ అండ్ సీన్? ఎప్పుడైనా బోర్డ్ ఓపెన్ చేసి చూసారా? మీరు చూస్తారు కానీ ఇక్కడ యాక్సిడెంటల్గా ద స్టార్టర్, if you open it and see, two cylinders will be there of begin size. They are also what? Capacitors. They are also capacitors. This capacitor, that capacitor size, if you compare, how they are? Same or different? Size is different. So automatically capacitor capacity is also going to be different. What is capacity? Actually, what is capacitor? Which stores some amount of energy. So energy stored in this capacitor, energy stored in those capacitors will be same. As the size is increasing, its capacitance is also going to increase. Means more amount of energy is going to store. Means depending upon the power, the gadget, the instrument, the electrical device is going to use. This capacitor, if you keep there and if you switch on the motor, it will run. Accordingly, they are manufacturing the capacitors. Even inside this also, motherboard will be there. Electronic gadgets motherboard will be there. On motherboard also different components are fixed. What are the different components which are fixed? Fabricated. Diodes, transistors, resistors, ICs, capacitors. Okay, see the size of the capacitor that is there inside the, on the motherboard, inside the computer or inside the electronic gadgets. Very small in size, but every capacitor, its capacity will be marked. Every capacitor's capacity will be marked in the form of 0.02, 0.01, 0.5, 0.55, like that. What is unit of capacity? Capacitance, capacitor. Farad. Unit is farad. But if you see, mu f will be there. What will be there? Microfarad or millifarad. Microfarad or millifarad, because farad is the largest unit. The capacitors that we use, capacitance will be either in millifarad or microfarad. Even, you know, fan regulator, modern fan regulators. What is fan regulator? For what purpose it is used? Fan regulator is used for to control the RPM. Have you opened and seen damaged one, spoiled one? If you open and see, inside also capacitors are there. Okay, old fan regulator contains coils. Old, which is big in size. Old fan regulators and paathavi 10 years back. Modern fan regulators, compact, and inside capacitors are there. Okay na? So capacitor is used to store some amount of energy. Now every capacitor will store some amount of energy. Same size capacitor, capacity I want to increase. I don't want to change the capacitor size, but I want to increase its storage capacity. Means the same capacitor. For example, if I take one size capacitor, let us say 1 microfarad. Its capacity is how much? Now I want to make this into 1.1 microfarad. Means capacity is going to increase or not. So what I can do? This has got a limit. That limit is 1. Excess, if you want to add, some changes you have to make. We have to increase the size, general. Because one example I took. The capacitor that we are using in fan, the capacitor that we are using in motor, same. Motor capacitance, motor capacitor's capacitance is higher than fan capacitor. Yes or no? Right. So if you want to make capacitors to store large amount of charge more than the required one, what I can do? What is the possibility? I have to change the dimensions. Size I have to change. But without changing, the symbol of capacitor is what? Parallel plate. Symbol of capacitor is parallel plate. Same dimension, different dimension. Length of the plate must be. Area of cross section will be same. Some distance gap will be there. Now this is the symbol of a capacitor. This capacitor will have some capacitance. Yes or no? What is the capacitance of this capacitor, which is given by the formula? Epsilon naught A by D. C is equal to epsilon naught A by D, where epsilon naught is called permittivity of the medium, A is the area of cross section of the plates, D is the distance between the plates. Now this capacitor's capacity is C. Now I want to increase this capacitor's capacitance without changing A and D. So what I do, we can increase the capacitor's capacitance by introducing one material. By introducing one material, that material is dielectric material. That material is what? Dielectric material. This is what? This rectangle is what? Dielectric material. Where it is kept? Between the plates. This material dielectric constant is K. So now after introducing dielectric material, its capacitance is C prime, which is equal to K times C. So C prime is larger than C, or C is larger than C prime? C dash or C prime is larger than C. So capacity has been increased or not? How many times? K times. So what is that K? Dielectric constant. K is what? Dielectric constant. Okay. So related to this material, that material is what? Dielectric material. Okay. So what are the uses of dielectric materials? They are used to increase the capacitor's capacitance. Dielectric materials are used to increase the capacitor's capacitance. Okay, clear? Now every material dielectric constant is K, that will be given, that by substituting you can find it. Now the question is, what are dielectric materials? What are dielectric materials? What are dielectric materials? I think now you got an idea that for what purpose dielectric materials are used. Idea vachinda? Dielectric materials are used to increase the capacitor's capacitance. Where what is capacitor? You know. Where capacitors are used in our daily life? You know. Telsa? There one in fan we are using capacitor. Motors capacitor. Okay. Capacitor's capacitance we can increase by introducing dielectric material. Now what is dielectric material? For understanding this dielectric material, we make use of insulator. We make use of insulator. Means with insulators we are going to know about dielectric materials. We try to get a knowledge about dielectric materials with the help of insulator. What are insulators? Sir, checks boy, beside. And the last two, they are sleeping for what? You ask them to stand. Okay. Here, black shirt, huh? What make you to sleep in the class stand? You only. For sleeping purpose you came to class. ఎందుకు పడుకున్నావు? నిద్ర వస్తుందా? Stand for some time. Okay. To understand about dielectric materials, we make use of insulators. Sir, can you speak about insulator? Can you speak about insulator? What are insulators? Or what is insulator? విన్నావా ఎప్పుడన్నా? చెప్. What is insulator? Anybody? What? Good. Which does not allow the bodies which does not allow current, they are called as insulators. The bodies which does not allow current, they are called as, example, wood, plastic, etc. Now, what we are discussing? Dielectrics. I'll say dielectrics are insulators. Dielectrics are insulators. But insulators are not dielectrics. Dielectrics are insulators, but insulators are not dielectrics. All dielectrics property, insulating properties only. But all insulators are not. One example is vacuum is an insulator, but it is not a dielectric. Right. All dielectrics are insulators, but all insulators are not dielectrics. Why? In what way? You are going to differentiate them. For understanding this concept, we make use of polarization. Polarization. By using this polarization, we can say where polarization is possible, the materials where polarization is possible, those materials are dielectric materials. And polarization is not possible, they are insulators. Polarization is possible, such materials are dielectrics. Not possible, insulators. Okay. Now the question is, what is polarization? When the polarization takes place? Adhe kada next vachedi. But dielectric we are comparing with insulators. What we said? All dielectrics are insulators, but all insulators are not. Okay, is it clear? Actually, what is the difference between insulator and conductor? Only one representation from this class, that too from boys side. Competition is coming. Okay, say, you also say. English. English. Good. You say in your words. Conductors allows current to pass through them. Insulators does not allow current to pass through them. So why? Why conductors allowing, insulators not allowing? Because of atoms. Atom is there everywhere. Because of ion. Because of the material. What is that material? Please listen to her answer. You are not saying and you are not listening when others are saying. Then what? You try to speak or you try to listen what others are saying. Okay? So example for conductors, metals. Okay, done. Paper, wood, plastic. Okay. In what way they are different? They are allowing current, they are not allowing current. Okay. Why they are allowing current, why they are not allowing current? Yes, that is your answer. Electrons. What are responsible for conduction? Electrons. Which electrons? Bonded electrons, free electrons. Where we find free electrons? Free electrons we are seeing in conductors, but absent in, not available in, means electrons are there, but which electrons? Bonded electrons, we can say it. Okay. Free electrons in conductors, bonded electrons in insulators. Those free electrons are responsible for conduction. Okay. Right. Coming to dielectrics and insulators. Polarization. What is the meaning of polarization? What is the meaning of polar? Not related to light. Yes. Okay. Speak. Unpolarized light. Again. Repeat again. Place. Listen when others are saying, or shut and sit. Don't speak. If you want to speak, stand. When your friend is answering, not listening, when I ask you to say, you won't open mouth. Then what? Yes. Yes. One direction of light, polarized light, unidirectional. Actually, unpolarized light, polarized light, but that polarization, this polarization is different. Okay. Right. Good. So he shared his knowledge regarding the first unit. One other property of light is polarization. Okay, done. Here, polarization is nothing but related to poles. What are the poles which are used here? Electrons, negative charge, protons, positive charge. Okay, they are called poles, I can say it. Right. When a polarization is going to take place, where polarization is possible, they are dielectric materials. Not possible, insulators. So, what is the meaning of polarization? Or when polarization is going to take place? External electric field is going to be applied. When we apply external electric field, if polarization is taking place, dielectrics, polarization is not taking place, insulators. Means what? For understanding this, let us take this is a body, solid. Okay, all solids made up of atoms. Atom is made up of electrons, protons, neutrons. How the arrangement of electrons, protons and neutrons? Nucleus. Nucleus is made up of protons and what is the charge of nucleus? Positive. And where we find electrons? Around the nucleus. So the circle is nothing but related to electron path. Yes or no? So what about the center of this nucleus and center of electrons? Coincided? Will not coincide. It will be coincided. This is the case. And atom is electrically neutral. Atom is electrically neutral or not? Yes. Why? Because equal number of electrons and protons are present in an atom. That's why we call it is neutral atom. Neutral. Now what I do? I am applying external field. Means here external field is 0. What I do? And a difference is there between these two. External electric field is 0 here. Some electric field I applied. What we are going to see now? So what did you notice? Any difference is there? Shape is changed. Good. Why the shape is changed? Electric field pushing the positive charge. Pushed kada. Center is pushed. So the negative electron center there only, positive electron center moved forward. Yes or no? So these are two charges. Two charges are created or not? Called poles. Called poles. How much some separation we can see it or not? Some separation is there or not between the centers of electrons and nucleus? The separation took place because of external field or not? If I remove this, what is the situation? When external field is applied, this is the situation. Yes or no? Absence of field, presence of field. Where this is happening, they are dielectric materials. If this is not happening, that is insulator only. Got the difference? So these are called poles. Polarization. What we say? What is this? What is insulator with respect to this figure? With respect to this figure, speak about insulator. For playing purpose. Then say. I seen. Right. Where this is possible, they are dielectrics. Not possible. So this is nothing but polarization, we can say it. Okay, na? Right. Here, how many poles are created? Called as dipoles. Actually, dielectric poles with respect to current. Because same poles terminology will come in magnetism. In magnetism also, north pole, south pole, there also pole will come. Okay, na? Here electric poles, positive and negative charges. Now, this positive or negative charge, strength will be equal or unequal of an atom. It will be equal. That is charge E, may be positive or negative. Now, these are separated with a distance. How much distance? Depends on A. If I increase A, what happened to D? Same or increases? Only D is going to change. D depends on E. D depends on E. Right. Negative charge or positive charge, that is charge E. May be positive or negative. Charge strength. Multiply with D. Multiplying with D. So you got a new term. What is that? Product of charge and separation between the charge. Distance between the charge. We call as mu. We call as mu. What is mu? Dipole moment. What we say? Dipole moment. Electric dipole moment. What we say? Electric dipole moment. So what is electric dipole moment? Product of charge strength multiplied with the separation between the charges. We call as dipole moment, or by with respect to current, electric dipole moment. What is the unit? Unit of charge is unit of charge. Unit of charge, coulomb, and distance meter. So coulomb meter. What is SI unit? Coulomb meter is a unit of mu. What is mu? But where is this mu depends on? Mu is depending on E. Field strength E. If E increases, D increases. Actually, if E increases, D increase. Means nothing but mu increase. So dipole moment directly proportional to E. I can write or not? Dipole moment is directly proportional to dipole moment is directly proportional to E. I can write or not? Okay, right. So from this, okay, mu is directly proportional to E, or okay, dipole moment is directly proportional to electric field E. Right. Right. Next, permittivity. Next word that we are going to say is permittivity. Okay. So what is permittivity? What is permittivity? It is a medium property. It is a medium property, and expression for permittivity is E is equal to D by E. E is equal to D by E, and it determines how easily we can polarize the nature of the medium. The medium will be undergoing polarized formation of poles. How easily it is going to be polarized, that information we are going to get from this concept, permittivity, indicated with letter epsilon. For free space or air, this permittivity is indicated with letter epsilon naught, which is equal to, calculated value is 8.85 into 10 power minus 12 farad per meter, or another unit is there. The another unit is coulomb square per Newton meter square. Coulomb square per Newton meter square for free space or air. For a particular medium, it is denoted with letter epsilon, permittivity of a medium. For free space or air, epsilon naught. Okay. Next, we can also find the ratio between these two. We can also find the ratio between these two, permittivity of a medium to permittivity of free space. That ratio we call as epsilon r, relative permittivity. What we say? Relative permittivity, or it is also called as dielectric constant. It is also called as dielectric constant. And the unit of permittivity is farad per meter or coulomb square per Newton meter square. What about the unit of epsilon r? Any units will be there? No. Why? Because it is a ratio between permittivity to permittivity. So any units will be there for ratios? There is no ratio. Okay. No units, and this will have some value. If the value is high, if the value is high, nothing but such bodies will be polarized easily. Such bodies will be polarized easily, and they show greater electrical insulators, or good electrical insulators. They can also show as good electrical insulators. Insulators means which allows, which does not allow. Electrical insulator means which does not allow electricity current. Good means they won't. When material whose dielectric constant is high. What is dielectric constant? Relative permittivity. What is relative permittivity? Ratio between permittivity of a medium to permittivity of free space. Okay. Next. The next that we are going to see is electric polarization. electric polarization. So what is electric polarization? Polarization means already got an idea. Polarization means already I said formation of poles, charges. When the charges are going to be created? When the body is exposed to external field by passing of current, by applying electric field. If inside the body, if charges are going to be separated, then we call as electric polarization. Okay. Now, from polarization, we define polarizability. Polarizability is alpha. What is polarizability? Previously, we studied about mu. What is mu? Dipole moment. Dipole moment is directly proportional to E. Dipole moment is directly proportional to E. Further, in the place of proportion, what I have to write here? Some constant, proportionality constant. That proportionality constant is alpha. What is a proportionality constant? Alpha. This alpha is called as polarizability. Alpha is called as polarizability. So from this, alpha is equal to what? Last two sleeping boys, no? పడుకుంటున్నారు కదమ్మా. So alpha is equal to what? Mu by E. Okay. What is mu? Dipole moment. E, electric field. Here, dipole moment will take place in the entire body. So we take average dipole moment. Mu bar by E, which is equal to alpha, called as polarizability. So how to define polarizability? If I take E is equal to 1 unit, what is alpha? For unit electric field, whatever the dipole moment that is going to be created, the dipole moment is called as its polarizability. Okay, na? Right. Next, polarization vector. Polarization vector P, or it is also called as polarization density. Polarization vector or polarization density. So polarization P, already you know, formation of poles. When the poles are going to form? When the material is exposed to external field. So P is directly proportional to E. I can write a polarization is directly proportional to E. I can write or not? So from this, P is equal to alpha E. P is equal to alpha E. For n number of atoms, P is equal to n alpha E. For n number of atoms, P is equal to, or n number of molecules which are present in the substance, polarization vector P is equal to what we can write? N alpha E. For in free space, P is equal to n alpha epsilon naught E. Expression for polarization vector in free space, n alpha epsilon naught E. Okay. Next, one more factor that we have to say, susceptibility. Electric susceptibility. Electric susceptibility. The symbol is The symbol is, pronounce it. Pronounce it. How you are going to pronounce it? Chia, Kaya, Saya. Your wish. CHI. Emanale. So, what is electric susceptibility? Actually, expression for electric susceptibility, because same term is used in magnetism also. That's why here we write electric E, electric susceptibility, which is nothing but psi is equal to P by E. Psi is equal to P by E. Okay. What is P and what is E? We discussed up to now. What is P? What is E? Polarization, electric field. Ratio between P and E gives you psi, electric susceptibility. So, what is electric susceptibility? How easily the material undergo polarization? That information we are going to get from this chi or psi. The mathematical form is psi is equal to P by E. Ratio between polarization to electric field gives you susceptibility. Electric susceptibility. The symbol is chi. Okay. Next, displacement vector. Dielectric displacement vector. Next topic is dielectric displacement vector. D is equal to epsilon naught E plus P. Expression is what? D is equal to epsilon naught E plus P. Expression for D. How to derive this? To derive this, we make use of capacitor concept as well as Gauss law. What is Gauss law? Integral E dot ds is equal to what? 1 by epsilon naught into Q. This is what? Gauss law. So, to derive this, what I do? I will take a parallel plates. Two plates connected to electric field, plus and minus. So, what charge is going to develop on this plate? This plate is connected to negative terminal, negative charge. So, Q charge is present on the plates, maybe positive, or boys are standing means there is a reason. Girls are also standing means what I have to say? The charge that is present on the plates of a Q charge. So, because of this, one electric field is going to set up from positive charge to negative charge. That electric field is E naught. Okay, na? Right. Apply Gauss law. What will come here? E integral ds is equal to 1 by epsilon naught into Q, because what charge is there? Q charge is there. E into this integration we take as A, which is equal to 1 by epsilon naught into Q. Further, E is equal to what? 1 by epsilon naught A into Q, which is equal to Q by epsilon naught A. E is equal to what? Q by epsilon naught A. Or shall I Drag the screen upside. Right. Idela? This is what? Gauss law in dielectric. Gauss law in electrostatistics. Where you studied? Intermediate. Remembering or not? Easy method of finding the E value related to closed surfaces. Okay. Same diagram with small change. This field is E naught, we said. Same diagram, copy it forward. What I do? One material is introduced. One material is introduced. On the material, charge is going to be present, induced charge. Plus means minus charge is going to induce here. Minus means plus charge is going to induce. The induced charge is Q prime. The charge on the plates is Q and the induced charge is Q prime. With respect to the charge which is present in the plates, the field is E naught in the downward direction, but induced charge direction is opposite to it. We represent with letter EP, means polarized charges, polarized charges. Therefore, net electric field is how much? Net electric field is how much? A naught minus EP. And the induced charge Q prime and the charge present on the plates Q is not equal. So, net charge is how much? Q minus Q prime. The net charge that is present is Q minus Q prime. Now, again use Gauss law. Again use Gauss law. What is that? Integral E dot ds is equal to how much? 1 by epsilon naught into Q. So, Gauss law for the leftover charge. What is the charge here? Q in the place of Q, what I have to take? Q minus Q prime. Means this equation what I can write now? Integral ds is equal to 1 by epsilon naught into Q. What is Q? Q minus Q prime. Okay, na? Right. E dot A is equal to 1 by epsilon naught into Q minus Q prime. From this E is equal to what? 1 by epsilon naught A into Q minus Q prime. Further simplifying, E is equal to Q by epsilon naught A minus Q prime by epsilon naught A. Okay. Over? Right. This side, if you bring, what will come, tell me? Q by epsilon naught A is equal to E plus Q prime by, okay na? Right. Q by epsilon naught A is equal to E plus 1 by epsilon naught into Q prime by A. q by epsilon naught a is equal to E plus 1 by epsilon naught into q prime by a. Now let here q prime by a is what? Q prime by a is equal to p, right? I am writing q prime by a as p. What is p? Polarization. What is polarization vector? Dipole moment for unit volume. Dipole moment for unit volume we call as polarization vector p. Dipole moment for unit volume. Denominator what must be there? Volume must be there. But here what is there? Area is there. Numerator what is there? Charge is there. But what is the definition of polarization? Dipole moment for unit volume. Numerator dipole moment must be there. Denominator that is equal to q prime by a. How? See here, q prime by a as it is I am writing. Okay. What I do? I multiply and divide with d. Any change in the equation? Any difference is there between these two equations? Both are same as per mathematics. In terms of mathematics, if same number is multiplied numerator and denominator, equation is going to change? No. Okay. Now, what is q prime? Generally, charge. What is q prime? Charge. Induced charge on the material that is kept between the plates. D, separation. What is D? Separation. We discussed in the first itself. Product of charge and the separation is dipole moment. It is mu. I can write a by A stands for area multiplied with D. Nothing but distance maybe in terms of height if you think. Then what it will come? Volume will come or not? Area into height. D is equal to height if you assume. Area into height will gives you volume. So q prime by A is equal to mu by V. Same or different now? But mu by V is equal to what we know? P. Therefore q prime by A is equal to what I can write? P. Now therefore equation is what? Q by epsilon naught A is equal to E plus 1 by epsilon naught into, I can write or not? Q prime by A. Q prime by A is what? I wrote P only. Simplify this. Q by A is equal to this epsilon, you take this side, epsilon into E plus P by epsilon naught. Okay. So from this, Q by A is what? Epsilon naught E plus epsilon P by epsilon naught. So Q by A is what? Which is equal to epsilon naught E plus P. So this epsilon naught E plus P I take as D. Therefore D is equal to what I can write now? Epsilon naught E plus P. D is equal to displacement vector. D is equal to epsilon naught E plus P. Okay. This epsilon naught E plus P we call as related to charges, P related to polarization, D related to displacement. And it is a vector quantity. It is a vector quantity given by D is equal to epsilon naught E plus P. Over? Writing is completed. Swami, over writing? Show your copy. యువర్ కాపీ, నాట్ హిస్ కాపీ. మరి ఏం చేస్తున్నావు? ఎందుకు వచ్చినావు మరి? యు వాంట్ బ్రేకా? చిన్న ఒక 5 minutes ఇద్దామా? ఆల్ ఆర్ గోయింగ్. 5 minutes ఇద్దాం. ఓకే, 5 minutes.
హలో, అరే రే కూర్చో ఒకసారి. ఫస్ట్ మీరు వెళ్ళండి.
Show your notes, Mr. Hemant. Show your notes. What you wrote till now? ఇప్పటిదాకా ఏం రాసావు? అంతేనా? షో ద డెరివేషన్. ఆ డెరివేషన్ చూపించండి సార్. ఇది నీ కాపీయా, అది నీ కాపీయా? మరి ఇదవది. మరి నిన్న అడుగుతున్నా, వాడి కాపీ ఎట్లా చూపిస్తావు? అయిపోయిందా? డయాగ్రామ్ ఏది? ఎప్పుడేస్తావు? హేమంత్ గారు ఎలా ఉండాలి? నిండుగా ఉన్నావు. బుక్ కూడా ఎట్లా ఉండాలి? ఎట్లా ఉండాలి? ఎంటీ ఉండాలా? ఎంటీ ఉండాలా? ఫుల్ ఉండాలా? ఎంటీ ఉండాలా బుక్లో? మరి ఏది? Second diagram. How many diagrams I drawn? Why I drawn diagram? Stand. Incomplete. Cap. Diagram ఏది సార్? యాడ్ చేయండి. లేదు. నెక్స్ట్. అయిపోయిందా డెరివేషన్? రీడ్ ద లాస్ట్ లైన్. మరి ఎప్పుడైపోతుంది? ఎప్పుడైపోతుంది సార్? నెక్స్ట్. డయాగ్రామ్స్. ఓకే. ఎస్. నెక్స్ట్. నెక్స్ట్. టర్న్ ద పేజ్. డెరివేషన్ పార్ట్ ఎప్పుడు రాస్తావు? నెక్స్ట్. గుడ్. సెట్. డయాగ్రామ్స్. ఓకే. నెక్స్ట్. డయాగ్రామ్. సార్ గుడ్. డయాగ్రామ్స్. ఓకే రైట్. నెక్స్ట్. 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 Please, all of you maintain silence. Next, next, turn the page. Yours. Next. Next. Diagram, second diagram. Add. Turn. Turn. Okay, good. Where? 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 Why I wrote? For what purpose I wrote? Okay, right hand show now. Write the. He wrote mistake, I'll say. What you will do? When they are writing, why you not wrote? Next. Okay, good. Left to right, iddar రాశారు. నువ్వేం చేస్తున్నారా? Next. Turn the page. Next. Diagram. Okay, good. Turn the page. Good. Next. Turn the page. Good. Good. Next. Okay. Okay. Next. Sir. Show your copy. Stand. Turn the page. Next. Next. Diagrams. Include the diagram. No, 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 no. Read the last line. Now you are writing stand. Stand. Diagrams. చూడు, మొబైల్ ఉన్నాక పని చేస్తుందా? దీన్ని తిప్పి పెట్టు. టర్న్ ద పేజ్. నో. గుడ్. వన్ మోర్ డయాగ్రామ్. ఇంక్లూడ్ ద డయాగ్రామ్. సెకండ్ డయాగ్రామ్. ఓకే. డన్. Done. Sir, show me your copy. Okay, good. Okay. Place. Sit and stand. Next. 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 Last. Stand. Sitting in the front desks and not writing means what? Next, sir. Why? No excuse. Next. Swami, where is the diagram? Now you copied, I know. Stand. Next. Complete the diagram, Swami. Done. Now you are writing yes or no? ఇప్పుడు రాస్తున్నావా అప్పుడు రాసావా? ఇప్పుడు రాసావా అప్పటి నుంచి? ఎప్పుడు వెళ్ళావు? మీరు ఎప్పుడు బయటకు వెళ్ళారు? బ్రేక్ ఇచ్చినాకనే ఇవ్వకముందా? మీరు వెళ్ళాక బ్రేక్ ఇచ్చాం కదా. డెరివేషన్ చేసినప్పుడు ఉన్నావా క్లాస్లో? అదే ఎట్లా వెళ్ళారు? ఎప్పుడు వెళ్ళారు? ఎంతసేపు వెళ్ళారు? ఏమా గర్ల్స్, ఐ విల్ కమ్ టు యూ, వెయిట్. ఐ డోంట్ వాంట్ టు లిసన్ ఎనీథింగ్ ప్లీజ్. నెక్స్ట్ షో. ఇప్పటిదాకా ఏం చేస్తున్నావు? electric susceptibility. Relative permittivity, electric susceptibility. To derive this relation, we make use of the equation that we derived just now. We know what we know. D is equal to epsilon naught E plus P. D is equal to epsilon naught E plus P. We also know what is P? Polarization vector P. N alpha E into E. P is equal to N alpha E into E. Here N is equal to 1. Or one more expression. Alpha E. P is equal to epsilon naught alpha E. Sorry. P is equal to, in terms of susceptibility, epsilon naught P is equal to epsilon naught psi of E into E, polarization vector. Substitute here, D is equal to what? Epsilon naught E plus epsilon naught psi of E into E. So what is common here? Epsilon naught E. What will come? Further, bring this E this side. D by E is what? Epsilon naught into 1 plus psi. Already we know D by E is what? Epsilon, which is equal to epsilon naught plus. Okay. We also know what is epsilon r. What is epsilon r? Epsilon by epsilon naught. From this epsilon is what? Substitute here. What will come? Tell me. Epsilon r, epsilon naught is equal to epsilon naught 1 plus psi. So epsilon naught you cancel. So epsilon r is equal to what? 1 plus psi. This is the relation between relative permittivity and electric susceptibility. So this equation and previous equation are important for solving problems. Okay. Here relative permeability is given means you can find electric susceptibility. If electric susceptibility is given, you can find relative permeability. And if you know relative permeability, we can also find permeability of a medium. Yes or no? Interrelated. Okay. Or if you write in terms of relative permeability, this I can write as epsilon by epsilon naught, which is equal to 1 plus psi. Like this also we can write or not. So the equation that we have to select according to the given data. What is given in the problem, accordingly we have to select the formula, we have to substitute and we have to simplify it. Okay. So this is about relation between relative permittivity and electric susceptibility, or dielectric constant and susceptibility. Next, what is alpha that we came to know? What is alpha? Yes. Rasa? Shall I? Why sound is coming? Over? Shall I? Over? Shall I? Shall I stop? Why sound is coming then? You are writing. Simply you are copying. Why sound is coming then? The next topic that we are going to say is types of polarization. There are three types of polarization. How many types? Three types. Electronic polarization, ionic polarization, orientation polarization. Electronic, ionic and orientation polarization. From electronic polarization, from the polarization we get polarizability. Yes or no? What is polarizability? Alpha. Alpha is equal to what? P by E. So polarization how many types? So automatically polarizability is how many types? Three types. Alpha E, alpha I, alpha O. Alpha E, electronic polarizability. Alpha I, ionic polarizability. Alpha O, orientation polarizability. Alpha E, 4 pi epsilon naught r cube. How much it is? 4 pi epsilon naught r cube. Alpha I, E square by omega naught square into 1 by small m plus 1 by capital M. Alpha O, which is equal to mu square by 3 kb into T. Mu square by 3 kb into T. So these are the types of polarizabilities: electronic polarizability, ionic polarizability, orientation polarizability. Expression for electronic polarizability is 4 pi epsilon naught r cube. Ionic polarizability is E square by omega naught square into 1 by small m plus 1 by capital M. Orientation polarizability is mu square by 3 kb into T. Now, actually derivation is there. This derivation, same concept. First we find dipole moment, then we find expression for force. Okay, then we get that by simplifying mathematics only. That will be discussed later on. Just we are going to see what is what regarding this. Electronic posability we are going to see in all substance. Electronic posability we are going to see in all substance. And expression for electronic posability is what? 4 pi epsilon naught r cube. So from this 4 pi epsilon naught constant, so directly what I can say, it is directly proportional to r cube. And here any time factor is there in that equation? T is there? No. So we say it is independent of time. What we say? Independent of time. Coming to this ionic polarizability. What is ionic polarizability? That polarizability that we are going to see in ionic substance. Ionic polarizability where we are going to notice in ionic substance. What is ionic substance? The substance in which ionic bond is present. or the substance contains or inside the substance ionic bond is going to present. Where this ionic bond, how an ionic bond is going to form? What is ionic bond? Bond between positive and negative charges. Those positive and negative charges are named as positive and negative charges are named as positive and negative charges are named as ఏముంది చేతిలో అయిపోయా మళ్ళీ ఫోన్ కాల్ వస్తుంది కట్ చేయి ఎంతసేపా ఆ మొబైల్ చూడకుండా కూడా కాల్ కట్ చేయొచ్చు అవసరమా ionic bond is formed by transfer of electrons between two atoms. Which atoms? Which atoms? Anions and actually atom changes into ion. How? By transfer of electron. So one atom loses electron, another atom gains electrons. So the atom which loses electron will become what charge? What charge it is going to develop? Positive. The other atom which is gaining electron, negative charge. So positively charged atom is called as blue shirt. Stand. Negatively charged, positively charged, cations, anions. Cations. Negatively charged, anions. The bond that is present between them, ionic bond. Where ionic bond is there? Ionic substance. Example for ionic substance? NaCl. General name for NaCl? Sodium chloride. Where it is used in our daily life? Salt. Where we use that salt? Curries. Eating salt. It is what? Eating salt. Okay. So sodium chloride, ionic anions and cations which are formed by transfer. Such substances are called as ionic substance. In ionic substance, ionic posability and expression is given by E square by omega naught square into 1 by small m plus 1 by capital M. Now in this, E is the constant, omega naught angular frequency inversely related and directly related to 1 by m plus 1 by capital M. And a temperature is there here. And a temperature is there in that equation. And a temperature term is there. No. So it is also independent of temperature. It is present only in ionic substance. If it is present in ionic substance, what about covalent substance? It is going to be absent. What are covalent substance? The substance in which covalent bond is present. What is covalent bond? How a covalent bond is going to form? Speak louder. Sharing of electrons. Covalent bond takes place. Sharing of electrons between two similar atoms or dissimilar atoms. The bond that is formed with sharing of electrons we call as which bond? Then what is ionic bond? Yes? Right. Next, the third possibility is alpha O. Orientation polarizability. Orientation means where we find this? Where dipoles are present. Where dipoles are present. Generally, dipole formation takes place only in the external field. But in some substance, even though there is no external field, dipoles will be present. They are randomly aligned. They are randomly aligned. Such bodies, when it is exposed to external field, random orientation changes to regular orientation. Random orientation changes to regular orientation, and they got polarizability. That polarizability given by mu square by 3 kb into t. What is mu? Dipole moment. Already dipoles are there or not? So mu 3 constant, kb Boltzmann constant. kb stands for Boltzmann constant. T stands for absolute temperature. So what I can say now? It is inversely proportional to temperature. So electronic and ionic possibilities are independent of temperature. Orientation possibility is dependent of temperature and that too inversely proportional. Okay. Electronic in all substance, ionic substance, orientation in where dipoles are going to present. Okay. Then after this, one more topic that we are going to see is internal field in solid. Low range method. Who gave this? Low range method. What is it? EI, which is equal to E plus P by 3 epsilon naught. Low range method of internal field. EI is equal to E plus P by 3 epsilon naught. Induced electric field EI, where the induced electric field inside the substance when the substance is exposed to external field E. P, polarization. Epsilon naught. Black shirt. What is epsilon naught? Stand. You only. Back. That. Two black shirts side by side. You only. First, second, third. Beside you. Yes. You only, sir. Tell me. What are you doing? What is epsilon naught? What I am saying about epsilon naught? Can you speak about epsilon naught? What it is called? Try to listen. Avoid phone. Right. So this is an expression for internal field. Who gave this? Lorentz. Okay, just we take a dielectric material where dielectric material is kept between two plates. So material contains atoms. Material contains atoms. Now this plate is connected to positive field for this negative field. So what charge is going to develop on this? Positive plate, positive, negative charge, negative. So from positive to negative, a field is going to set up. That field is E1. This positive plate, when you introduce a dielectric material, negative charge is going to induce. On this negative plate, positive charge is going to induce. And in which direction? In the direction of field or opposite? Opposite. Now, this solid is made up of atom. One atom I am taking, which is spherical in shape. Okay, right. On the surface of the sphere also, charge is going to induce. Dipoles are going to be created, induced. Here negative means which charge is going to induce? Positive. Positive means negative. Again from positive to negative, one more field is going to set up or not? That field I call as E3. So finally, what Lorentz said that the field that is developed inside the material is EI, which can be taken as E1 plus E2 plus E3 plus E4. One more I am going to add. Who said? Lorentz. What is it? When a dielectric material, when it is introduced or when you apply a field E, the field that is going to be set up is EI, which is nothing but sum of E1 plus E2 plus E3 plus E4. According to him, E1 is equal to D by epsilon naught. E1 is equal to what? D by epsilon naught. But what is D? Just now we seen. What is D? Epsilon naught E plus D is equal to D is equal to epsilon naught E plus P by epsilon naught I can write or not? Already we have seen this derivation, seen or not? So if you simplify, what will come? Epsilon naught E by epsilon naught plus P by epsilon naught. So which is equal to what? Which is equal to E plus P by epsilon naught. What it is? E1 field. Next, E2. E2 is what? Induced one. And what about the direction of E2 with respect to E1? Opposite. Only polarization we are going to see, which is given by minus P by epsilon naught. Next, E3. E3 derivation is there, that is already downloaded. It will be shared later on after this. Okay, whose value is P by 3 epsilon naught. I will show you 2 pages derivation is there, that you can check out. Pure mathematics. What we do, we take this sphere, we take the part of the sphere whose area of cross section dA, we find dq, from dA we find dq, from dq we find E, then that E on integration we get E3 like that. Next, E4 I will take as 0. E4 with respect to other atoms which are present, and we consider that there are no other atoms. So field with respect to E4 is 0. Therefore, what is EI? E1 plus E2 plus E3 plus E4. What is E1? E plus P by epsilon naught. What is E2? Minus P by epsilon naught. What is E3? What is E4? So this is cancelled. Therefore, EI is equal to what? E plus P by 3 epsilon naught. This is given by whom? Lorentz. Lorentz method of internal field in a solid. Means when a solid is, when you keep that solid in an electric field E, the field that is going to be seen in the solid is EI, which is equal to applied field E plus P by 3 epsilon naught. Means additional factor is going to be seen, P by 3 epsilon naught, with respect to the applied field. Who gave this? Lorentz. Because this equation we are using to derive one more concept that we are going to know after this. China, morning download chesina oka papers unnai. How to see? This derivation part for this. See, is it visible last? Not visible also, no problem. Okay, don't respond. So A1 is there, E2 because of induced charges, only polarization opposite direction minus P by epsilon naught. E3 field intensity due to polarized charge on a sphere cavity calculated by using Lorentz method. That is a method. So this is a sphere. Okay, what we do, we select this area dA, the charge, because I want to know how much charge is present on the entire sphere. So not possible. A part of the sphere we are taking, we are finding the area of that, from that area charge, from that charge field. Okay, dA. For that purpose, this mathematics, dA is equal to 2 pi times PQ times QR. PQ and QR. The product of these three gives you area of the selected region, the small region. Back. How to come back? China. Back. Next. Into na? Right. See, dA is equal to what we are getting? 2 pi r square sin square theta d theta, complete mathematics. Now the charge present on dA is dq, which is nothing but p cos theta into dA. How this I'll say? Because direction, resolution of vector concept. So dq is equal to pa cos theta into dA. That dA we are substituting and simplifying. So dq is equal to what is coming? P into 2 pi r square sin theta cos theta d theta. The field due to this charge at A is dA3 theta 0 direction cos theta. So this formula for electric field E is equal to 1 by 4 pi epsilon naught q by r square. E is equal to F by Q. Electric field intensity E is equal to F by Q. F is equal to E into Q. E is equal to 1 by 4 pi epsilon naught q by r square according to that formula. Okay. dq already we found here. P 2 pi r square sin theta cos theta, that I am substituting. Simplified. Then we are going to get d3. What is d3? P by 2 epsilon naught cos square theta sin theta d theta. Now I want total sphere. Part only I took, dA part. Entire sphere means what I have to do? Integrate. So upon integrating d3 e3, which is equal to 0 to pi, this value P by 2 epsilon naught cos square theta sin theta d theta. Right. Integration concept. Okay. So dE3 upon integrating E3, upon simplifying, what is coming? E3 is equal to P by 3 epsilon, pure mathematics. Okay. So in this way we are going to get E3, E4 0. What is EI? E1 plus E2 plus E3 plus E4. తర్వాత afterwards. Okay, just I am giving you the derivation part. Okay, for what? For which field? DE3 only. Okay, screen screen back. Okay, SB క్లోజ్ చేయాలా? అబ్బో వాళ్ళకి చెప్తున్నా. Done. Okay na? Understood? That part you can get later on. So this is what? Internal field in solid according to which method? According to Lorentz method. Okay na? Right. Next one more topic that we are going to see, that is, okay, one is missing. What is alpha I? Ionic possibility. Alpha O, orientation possibility. Alpha E, alpha I plus alpha E plus alpha O is nothing but space charge possibility. By joining them, by adding them, we get a space charge possibility, means space charge polarization. P is equal to n alpha E, where alpha is alpha S, which is equal to this one. So P is equal to n into alpha I plus alpha E plus alpha O into E. This is what? Space charge polarization, space charge possibility, by adding the individual possibilities. Okay, electronic ionic orientation, if you add, if you sum, then we get a polarizability, that is called as space charge possibility, or the polarization, what we have to say, space charge polarization. In simple ga వాటిని ఏం చేయాలి? యాడ్ చేయాలి. Okay, next Clausius Mossetti relation. Clausius-Mossetti relation is one more topic that we are going to see, which is given as epsilon r minus 1 by epsilon r plus 2, which is equal to n alpha e by 3 epsilon naught. Clausius-Mossetti relation. This is the mathematical form for that heading. So this question will be asked in three ways. Three possibilities are there. Derive Clausius-Mossetti relation, direct question. Second, he will give the derivation, he will give this title, he will ask you to derive. Third one, write the relation between epsilon r, alpha e and epsilon naught. Relation between what? Epsilon r, alpha e, epsilon naught. Write the relation, derive the relation between epsilon r, alpha e, epsilon naught. One type. R. What is epsilon r? Relative permittivity or dielectric constant. What is alpha e? Electronic posability. What is alpha epsilon o? Permittivity of free space. Write the relation between or derive the relation between relative permittivity, electronic posability and permittivity of free space. In this way the question may be asked. Okay. Direct or Clausius-Mossetti only will say. Derive the Clausius-Mossetti relation or derive the relation between epsilon r, alpha e, epsilon naught, or derive the relation between dielectric constant, electronic posability, permittivity of free space. Anyway the question may be asked. Okay na? Right. To derive this, we make use of polarization. We make use of to derive this, we consider a material, a solid. We take a solid. Which type of solid? Solid free from ions. Solid free from ions and no permanent dipoles. No ions, no dipoles. Yes. Only. Back. Please stand. What are you searching for? What I said about this diagram? Did I said anything else about this diagram? What it is? What it is? You won't listen. You won't respond. You won't write. Then why are you here? For what purpose you are here? Can't you feel shame? Sigganpiyada? Many students want for the sake of mobiles. Okay, I'll wait. Check. Using mobile? Yes or no? ఏం చేస్తున్నావు మరి రాయట్లేదబ్బా నిజం చెప్పు అబద్ధం వద్దు సే ద ట్రూత్ సే ద ట్రూత్ నో ప్రాబ్లం వాట్ ఆర్ యూ డూయింగ్ నో యు ఆర్ నాట్ రైటింగ్ ఐ నో when I am looking at him he is writing sir beside say the truth నిజం చెప్పేందుకు నేర్చుకో you are not writing that confidence is there CC camera unte I can show it I drawn this diagram for what వింటున్నావా మరి okay వింటున్నావా you are writing na listening what I am saying show your copy once what did you write last line done Press. Show. Again you show. Tip. Set. Right. What is this? It is a solid. What type of solid? Free from ions. Free from ions. And free from dipoles. Free from ions means no ions. No cation, no anion. If there are no cations and no anions, ఏం కవరింగ్ అమ్మా కానీ I'll wait. I know what the hand is doing and your friend also know. So no ions. Which porosity will be missing? Ionic. So alpha is no dipoles. Which porosity is 0? No dipoles. Which polarizability is 0? So which polarizability is present here? Which is alpha E. Right. So from the definition of polarization P, actually P is equal to what we know? Definition of polarization, P is equal to N alpha E. Here, what is alpha? Alpha is equal to alpha E only or not? And what is E? According to low range method. According to low range method, E is equal to EI. And alpha, what I will take? Only alpha E. Why? Why I am not taking alpha I or alpha O? Because which type of material we selected? Free from ions as well as free from dipoles. Ionic possibility is 0, orientation possibility is 0. Only electronic possibility is there. That's why alpha is equal to alpha E. Okay, na? Sir, hero, use pen. Don't take photo. First make a habit of writing. Exam lo mobile use చేస్తావా పెన్ యూజ్ చేస్తావా? ఇది కూడా రాయలేకపోతే ఏంట్లా? అంత బిజీయా సార్ మీరు? ఎగ్జామ్లో ఏం రాస్తారు సార్? మొబైల్ ఈజ్ అలౌడా? Smart work makes people smarter. For dash, fill the dash. Right. So therefore P is equal to what? N alpha E into, I can write this equation I am replacing with this equation. Okay. But we know what is alpha E? What is alpha E expression? 4 pi epsilon naught r cube. And low range field of internal field EI. E plus P by 3 epsilon naught. Antena? Substitute now. Therefore P is equal to what? So P is equal to, okay. This one afterwards. This one I'll substitute afterwards. N alpha E into EI. What is EI? E plus P by 3 epsilon naught. Alpha E value afterwards. Done. Multiply. P is equal to what? N alpha E plus N alpha E P by 3 epsilon naught. Okay na? P this side, or this time you bring this side. N alpha E is equal to how much? P minus n alpha e p by 3 epsilon naught. So n alpha e into e, what I can take outside? P 1 minus n alpha e by 3 epsilon naught. So from this, P is equal to what? N alpha e by 1 minus n alpha e by 3 epsilon naught. This is equation 1. P is equal to n alpha e by 1 minus n alpha e by 3 epsilon naught. Okay, na? Right. Over? We know D is equal to displacement vector. D is equal to D is equal to what? Sir, where? రమ్మన్నాడా క్లాస్లో ఉన్నావు అని చెప్పలే క్లాస్లో ఉన్నావు అని చెప్పినా ఫస్ట్ రమ్మని చెప్పారా అట్లా కూడా ఉంటుందా నీ ఫోన్ లేకపోతే వచ్చేవాడికి ఇక్కడికి బాగా నేర్చుకున్నారు రీజన్స్ మేడం ఐ డిడ్ంట్ పర్మిట్ హిమ్ సార్ మిస్టర్ వాట్ ఈస్ హిస్ నేమ్ Mr. Hero, show your copy once. What did you write? Read the last line. Read the last line that you wrote. Going back, why? Read the last line. Huh? Read the last line. Huh? Amma, please. ఇది టాపిక్ ప్రీవియస్ టాపిక్ దట్ ఇస్ ఇప్పుడు నేను అడ్మిషన్ చేసిన వాళ్ళు ఉన్నారు కదా వాళ్ళని పిలిపిగా ఎందుకు వేసారు అడుగుతా నేను ఫీల్ షేమ్ you want a reason to skip or you want a reason for going out from the class. What you are going to write in the exam, man? What you will be writing in the exam? Equation previously equation చూసావా కనిపిస్తుందా what is it? read place ఇది అయిపోయింది d is equal to epsilon naught e plus p డెరివేషన్ గుర్తుందా d అంటే డిస్ప్లేస్మెంట్ వెక్టర్ p అంటే పోలరైజేషన్ epsilon naught అంటే ప్లేస్ permittivity of free space. E stands for electric field strength. Okay, good. Right. From this equation you write P. So P is equal to what? Minus epsilon E. P is equal to D minus epsilon E. What is D? Okay, bring this P is P by E is equal to d by E minus epsilon naught. But we know what is d by E? Permittivity. So from this, P by E is what? Epsilon minus epsilon naught. We also know what is epsilon r? Epsilon by epsilon naught. From this, epsilon is what? Epsilon r epsilon naught. So P by E is what? In the place of epsilon r my epsilon r epsilon naught minus epsilon naught. P is equal to what? What is common here? Epsilon naught. Epsilon r minus 1 into E. Right? Right. What is equation 1 and what is equation 2 represents? Both are equated for what? Both are equated for P. Okay. Right. Yes. Shall I? Over. Shall I change the screen? Amma, yellow shirt, yellow dress. Screen marchala. Right. Thank you. Right. From equation from equation 1 and 2. What can I tell me? N alpha E by 1 minus N alpha E by 3 epsilon naught is equal to P. P is equal to epsilon naught into epsilon r minus 1 into both are related to P. So equated. So if you cancel E and rearrange the terms, what will come? N alpha E by epsilon naught into epsilon r minus 1 is equal to 1 minus N alpha E by 3 epsilon naught. Now mathematics. Okay. Shall I? What happened? Right. Bring this term this side. N alpha E by epsilon naught epsilon r minus 1 plus N alpha E by 3 epsilon naught is equal to 1. What is common now? N alpha E by epsilon naught. So 1 by epsilon r minus 1 plus 1 by 3 is equal to 1. So N alpha E by epsilon naught LCM. What will come? 3 into 1? 3 plus epsilon r minus 1 by 3 into epsilon r minus 1 is equal to 1. Simplify this. N alpha E by epsilon naught 3 plus epsilon r minus 1 is equal to how much? Epsilon r plus 2 by 3 if I take outside epsilon r minus 1 is equal to 1. I took this 3 outside. So from this N alpha E by 3 epsilon naught is equal to epsilon r minus 1 by S long R plus 2. Okay. So this is what?